All right, so we are jumping into Unit 3, which is going to cover Boolean expressions and if statements as the name of our unit. Today, we are going to be discussing Boolean expressions and what that even means. So, a recap of what Booleans are in general. A Boolean variable is used to store either true or false. It can only be one of those two values. It can only be true or false. Boolean is a primitive type, although like other primitive types, it has a wrapper class. We can use the Boolean with a capital B class to represent the same kind of information. And a Boolean value is best thought of as like the answer to a yes or no question. So like the sky is blue, that would be true. It is raining right now, that would be false. So yes or no questions, there we go. So something we can do to get Boolean values is use these relational operators. They're also known as comparison operators, and they are used to compare two values against one another. So we have 6 total relational operators. We have the double equals, which is going to check if the values on the left and right are equal to each other. We have the not equals, which is going to check are the values on the left and right not the same as each other. And each of these is going to give us true or false, depending on if their condition is met. So if I have variables, let's say x and y, if x and y here are the same as each other, then I will get true. If x and y are different, I will get false. With not equal to, I'm going to check if the things are different from each other. I can check for greater than and less than. And I can also check for greater than or equal to and less than or equal to. So with numbers, this all makes a lot of sense. We can just check if numbers are the same, if they're bigger or smaller than each other. All that just kind of tracks, right? Numbers make sense, like we can use these to compare things. Sweet. Cool. All right. So these relational operators will work with any primitive data type. We can use them with ints, we can use them with doubles. We can use them with Booleans, although it doesn't make much sense to compare a Boolean with another Boolean if we can just use a Boolean. So if I'm comparing x and y, which are 10 and 5, and I make my Boolean compare equal x greater than y, will that be true or false? That'll be true, right? Because 10 is greater than 5, so that's going to be true. So when I print line compare, it's going to say true. If I make 2 doubles, v and w, equaling 3.6 and 3.12, is v less than w? V is not less than w because 3.6 is not smaller than 3.2, so that's going to give me false. There's our 2 answers. So let's do a couple of practice problems. If I'm getting some input from the user, some grade, and I want to check if the user has an A, what Boolean expression would I use to determine if that grade is an A? Let's say the cutoff point is 90%. I could do if my grade is greater than or equal to 90. Is there an alternative?
Well, I was going to say greater than 89, assuming it's 92.
Or I could do greater than 89, right? Because in either case, I'm going to check, it's going to include the number 90 and look at everything above it. So either one of those will work here. Boom. Both of those are perfectly valid here. If I want to check if the the letter variable is equal to the letter Q, I want to say true when the letter is Q and false when it's not Q, what comparison operator am I going to use? We're going to use our double equal. I'm going to trip over things. We're going to check if letter double equals that character Q, and we can check, are those letters the same? This one will obviously give us false because A is not the same as Q, so that one will give us false, but for now, whatever letter we use, we can check if it equals the letter Q. I don't know why I put false here because this isn't actually making a check. So in Java, is something to remember is that the one equal sign is used to assign a value to a variable. Two equal signs are used to compare two values against each other. So it is very easy to remember to forget to use two equal signs when you're trying to check. I do it all the time. So just remember, when you're comparing values, you want to use two equal signs. You only use one equal sign when you're assigning a value. And I promise it's going to happen. You're going to make the mistake. I've made the mistake countless times. So just be aware it's going to happen. All right. So all of those relational values or relational operators will work with all of our primitive types just fine. But just so you know, it is possible to use the double equals and the not equals to operators to compare reference type values. However, this might not work like you expect. So let's look at this. Let's say I have rect1 equaling a rectangle with width for height 5. Rect2 is a rectangle with width 6 and height 7. If I say rect1 double equals rect2, are those rectangles going to be the same?
Yeah, it doesn't look like it.
It doesn't look like it. Those two rectangles are definitely not the same. They have different widths and heights, definitely not the same rectangle. What if I change my rect2 to have the same width and height though? Will those now be the same rectangle?
Yeah.
All right, I have a guess for yes.
Something tells me it's going to be no, but it really looks like they're the exact same.
All right, so I have a guess for yes. They look the exact same. Ryan, I saw you with your thumbs down. Why do you think no?
They're different instances, so I'm wondering if that has something to do with it.
All right, that's a good intuition. And the answer is that it will be false. Because when we compare two relational operator, or compare any two values with relational operators, it's going to compare the value stored in that variable's box. So a primitive value, so if I have an int x, its box is going to have some number in it. If I have an object though, if I have like a string y, the inside of its box is some reference. It's going to be a memory address pointing towards some object data. And so reference type variables, when I use those comparison operators, when I use those relational operators, it's going to compare that reference against the other reference rather than trying to compare our actual object data. So what we need to do is we have methods to actually compare objects against each other. That's why we use the dot equals and dot compare to methods with strings, because we're checking, are these things actually the same or not? Rather than comparing the references, which honestly isn't going to be very helpful. Checking memory addresses against each other doesn't mean a whole lot to us. What we want to do is we want to make some comparison method that's going to actually check our object data against another object's data, so we're not comparing references. Does the reasoning behind that make sense? You cool? No. Sweet. Clear that. All right, so let's write a practice problem where we ask the user for their age and then print out whether they are old enough to vote. So what steps do we need to do that?
Scanner.
So we need to do user input. So user input and ask for age. Then what?
And then you could use like a Boolean and then compare the input and see if it's greater than or equal to 18.
Compare the input to 18. And then we would just print. All right, those seem like some good steps. If I do that, boom, we have the same exact 3 steps. So step 1, we've done user input already. We're gonna make a new scanner object. We're gonna ask the user enter their age. We're gonna get the next answer. Boom, super easy. Making a Boolean variable to store whether the user's age is greater than or equal to 18. So we are going to use the greater than or equal to operator with age and just the number 18. And we can save that into some Boolean variable. Boom, Boolean old enough to vote is going to equal age greater than or equal to 18. So if their age is old enough, we'll say, hey, you're old enough to vote. Congratulations. We will say old enough, and then whatever value is held in that Boolean value or that Boolean variable. So if old enough to vote is true, we'll say true, you are old enough to vote. If they entered a number less than 18, we'll say old enough is false. You are not old enough to vote. Does that all make sense? Tracking? Take the resounding silence as a yes. All right, well, that is it for our lesson today. So